screen.
Okay.
Okay. Can you see my screen?
Yep, looks good. So if you want to start, Whitney, start recording.
Yeah, started. Yeah.
Great.
Yeah.
All right, Kevin,
Yeah.
I'll let you go.
Okay, cool. Thanks, Bill. So today I'm going to introduce a bit about our early work on MPP, which is a federated GPU tooling framework for orchestrated and LLM agentic profiling applications. So it's pretty early, and but we have some interesting results. So the background of this work is basically we have seen some exciting advancements in this Triton ecosystem, including EDSLs and Proton. For example, we have some interesting low-level DSL like Gluon, TX, right? These give you the ability to scale your performance if you are not happy with the high-level Triton DSL. So you can go one level deep and learn more about synchronization and this GPU low-level knowledge and get some performance boost. And on the other hand, on the provider side, we have some joint work with OpenAI, especially Current, on this Proton intrakernel profiler that offers some unique perspective in the profiling space. And specifically, there are four new dimensions. First, Proton intrakernel profiler is compiler integrated, and it has DSL support. It gives you the ability to view structural level timeline for Triton or Gluon TX programs, and it gives you OP level latency. So when the intrakernel profiler work with like Triton, Gluon, TLX, we have different approaches to work with them at different abstraction level. But you can, it's not very, in some sense, some approaches are not very handy. For example, like if you operate at the TTGR level, you need to use the Proton dialect using some override technique to do this. It's not very handy, but we want to make another layer on top of it to make things have a unified interface and have some controller to do this in a coherent way. So the question is how we leverage these new profiling dimensions like I've discussed before. It is interesting that if you look at these new dimensions, it turns out when you combine with traditional existing or classic profiling tools, performance tools, you can create some interesting applications or support existing applications like some advanced profilers, LLM agent, auto-tune, PGO, things like that. But in order to support these applications, we need to design a system that has the following requirements. The first one is the programmable interfaces. So it's true that you can use the CLI to pass a bunch of arguments, for example, NCU, right? You can pass a very long arguments and deal with them. For NVBit, you do this another way, right? And then manually do this multiple passes to either you post-processor trace or instrument your program, right? But that's not the ideal. We want the unified, coherent programming interface to call these functionalities. Second is eager execution. We want to simplify the use of the system. So if it's lazy execution, it's pretty hard to debug if you have some errors. Third is parallelization, especially when you have multiple GPUs, you want to fully utilize them to finish your job faster. Fourth one is sandboxing. This is especially important when you try to create an LLM agent that you want to enable it to do trial and error, to basically let the agent to do some experiments, and if it fails, you can go back and do again, right? Cleaning up the artifacts and stuff like that. because you have those caches, you have the temporary TTR, TTR, right? The kind of thing you want to delete those temporary stuff and make sure you are in a clean environment. And debuggability for torrents, basically when you, for example, when you do some statistical profiling, you don't want, you meet some errors, some weird error, you don't want to start again. You want some checkpoints that you can just recover and proceed. So these are the requirements, and we developed an early prototype, the MPP prototype, and the program model is fairly simple. So we define some first-class citizen, the data structure, like program IR, execution trace, performance report. These are the first-class data type. You can operate with these data structure, and they are the first-class citizen. So you are able to, for example, merge traces, concat trace, and compose those IR, and you can operate on these objects. Then we have some runtime abstractions. For example, task and the job. Task is basically the unit, the primitive of the action. Like for example, you trigger NCU profiling on get the tensor quantization, something like that. The job is basically a task control flow graph to let you to construct this workflow, this profiling workflow. So the figure on the right is an example of how you program this thing. You define task, and you also use the defined task to construct a trace job, which is a task graph. In the init function, you specify the connection of these tasks, and in the run function, you run them eagerly. It's pretty much like PyTorch kind of style. And the job can be nested because that's this is a unit of reuse. For example, you have a workflow that give you some asynchronous latency for some operations, and you have another workflow that give you some timeline on your producer-consumer relationship. Then you combine these two workflow by reusing them. You can easily create another workflow that give you both, right? So the system, this is the high-level system architecture. It essentially consists of three parts. One is the job specification, which is a nested control flow graph, and our runtime system, the scheduler, can dynamically resolve the dependency and try to maximize its parallelization. So we maintain the eager execution illusion, the abstraction, and try to maximize the parallelism across multi-GPUs. So the task scheduler will schedule those tasks, profiling task, and also the eager executor will connect to a backend resource pool with CPU and GPUs, and checking or store the states in some persistent. We use persistent data store to store the intermediate states for error recovery. Yeah. So these are the high-level description about the system. Then let's look at some case studies. The first one is profiling asynchronous operations. For example, like these are pretty common for Triton programs, right? If you have some matmore and you want to hide the latency of memory loading and the computation, then you want to estimate how long the asynchronous operation takes. So in MPP, we handle this by profiling, constructing statistical traces or profiling results. These asynchronous operations are tricky because some of them have big variance because they share resources. Like either like the TMA or the you load data using CUDA core. They share the memory system, right? So it's not that accurate if you just measure it once. We developed some method that you are able to see the statistical latency across iterations. And for example, the two figures above, right? You can visualize the median latency, and you can also see the percentile that, for example, for this async copy, right? Roughly how long it takes. Then you in your mental model, you can construct this computation this model and try to how you optimize it. And then we also the figure in bottom basically some like cross validation. We use our approach to measure the data transfer time for TMA or WGMMA, and they should be proportional to the data size, and it's expected, right? So yeah, and with this measurement, you can also have a statistical timeline view for those asynchronous operations. In the Proton alone, you can see the scoped regional timeline. But for asynchronous operations, you are able to see the issue time and the wait time, but you don't know when it ends unless you have some wait time, right? So combined with the statistical trace, you are able to see the average execution time for this asynchronous operation and the percentile, like P20, P50, P80, like for this operation, how long does it take? The second case study is to leverage MPP to construct a PGO agent to optimize Triton kernels. So we implement interesting PGO agent, which has three sub-agents. The first one is profiling agent, the profiling phase. We have multiple agents to profile the program, the Triton kernel from different perspective. For example, one agent looks at the synchronous data loading like perspective. The other one look at the tensor co-utilization. The third one look at some synchronization stuff. So the profiling phase will automatically use MPP to get the profiling results. The second phase is a summary phase because the profiling results is the context window is pretty big. We want to compress it. So we ask the summary agent to give us TLDR information. So yeah, just basically this step is to compress the content. The third one is the optimization phase based on the profiling results. For example, for this operation, for this load, how long did it take? For this loop, how long did it take? How long is your computation? How you overlap them? Based on this measured information, the optimizer agent will generate a optimization strategy that will write your kernel to improve the performance. So during the development of this work, we are using the TDGR because TLX is not and Gluon is not ready. So we're experimenting this in the TDGR fashion. So here are some examples that what agent can do. These are the snapshots for analysis and the profiling. So we asked the agent to look at the kernel, the TDGR kernel, and ask it to summarize what's going on there. And then you can see that the agent is able to tell the structure, some potential performance bottleneck. And then we ask the agent to design a profiling like strategy to profile based on your observation, this analysis. And then it summarize the profiling result. For example, for this producer pipeline characteristics, like it finds there are significant variance in inner loop execution, like, and it can also tell you like what are the iteration that has high variation, what are the with low variation, and it also will analyze the consumer, the critical path, try to shorten the critical path of your kernel. So then with these two results, with these two information, the optimizer agent will try to rewrite your TDGR. These are the two snapshots, one on the producer side, the other on the consumer side. For example, here it finds that the tile A and the tile B, it reorders tile A load and tile B load because tile B has more higher variance. The loading time has higher variance, so it reorder the loading. And for the consumer side, it play around with the interleaved iteration and the barrier thing. Try to overlap asynchronous operations to play with those barriers. Yeah. And we test this on the TLX, manually optimize the TLX persistent gem kernel, and using the cloud Opus 4.1 backbone LLM. And we did a few comparisons. First one is the baseline, like the Triton TLX. The third one is the agent without using the profiler. Or the second one is the agent without using the profiler. The third one is the agent using NCU. The fourth one is the agent using MPP. And we can see that in all cases, the PGO agent with using MPP can achieve the best. It's almost on average, it's like 7.6 performance speed up compared to the Triton TLX, which is already being hand optimized. Compared to like the agent without profiling or agent using NCU, you can see sometimes even with NCU, the performance degrades. So we suspect that because this coarse-grained NCU profiling, which is sampling based, right? And it's high-level sampling based, it confuses the agent, which made the wrong decision about how to optimize. That's why it degrades performance. And the baseline agent is based on like common knowledge without the actual profiling data. It tried its best to optimize, but it can never beat the one with the profiler because we have more real data. There are some cases that fails. One is the kernel results changed. The other is the agent mess up the timing, which causes a deadlock. So these are the two common cases when optimization fails. For the deadlock, there is also an interesting observation that without profiler, the agent, without the MPP profiler, the agent is pretty much likely to get deadlock. So it's more frequent than the one we have profiler, which is able to understand the timing information and try to avoid deadlock. So that's pretty interesting. The third case study is about the fine-grained metrics via tool composition. For example, we use the Triton flash attention tutorial and get the timing information from Proton Central Kernel Profiler and get the instruction stats from the NV-bit or CU Tracer. CU Tracer is our in-house runtime instrumentation tool to get some various SAS level information. Like we can do regional IPC analysis. For example, we measure 3 regions in this flash attention tutorial. One is element-wise, which achieves 4.0 IPC, 4 instruction per cycle, which is expected because you have 4 sub-partitions and 1 instruction per clock. Second one is softmax, which has lower IPC, which is expected, right? You have a bunch. The figure on the right to show you the instruction mix. You have more data movement in this region, and it's lower IPC. And for the loop the entire loop, it's even lower because you have more like synchronization, memory ops, kind of load store kind of stuff. Yeah, that's a very intuitive way for you to observe some, for example, for a mass pipeline. If you try to see like whether for this piece of chunk of code is maximize your throughput, mass throughput, something like that. You can also get information, for example, register pressure. We can use Proton, for example, PL enter scope for user to annotate the kernel, and we can get the register information from NVIDIA disassembler, and we can combine them. We can do a post process and aggregate the register, the max register, so we get register pressure. And it might be useful for like the cases that we need to tweak a number of registers. For example, warp specialization, we want to manually allocate. Sometimes we want to manually allocate the number of registers allocate to each worker, right? So that gives you some handy way to do this. So in conclusion, Proton itself is very powerful and opens up a new profiling space. MPP builds on top of Proton, enabling rich applications via orchestrated profiling workflows. For example, we can build advanced profilers and even like some Triton kernel optimization agent based on MPP's capability. It will be open source when it becomes mature, so it's pretty early stage now. So yeah, keep staying tuned. Yeah. Thank you. And any questions or suggestions?
Yes, I have a question on I think just the last slide or the one before that. Okay, so here you get the register information by disassembling the NVIDIA binary. How easy or how difficult is to hook up different type of disassembler, for example, AMD or other GPU vendor? I don't know if you already hooked up something from AMD to prove that the tool can be used with different backend toolchain.
MPP itself is just a federated framework. It's just for the backend integration, it's basically a wrapper. So whatever the backend thing can give you, it can like post process. We haven't tried AMD. We just did an early prototype on NVIDIA because AMD we cannot do warp specialization, right? So we don't see a lot of use case in the AMD. But in theory, nothing prevents you to do that. As long as you can get these things from, for example, command line, you can integrate with MPP with some nice abstraction for programmability, right?
Okay, that's good that the interface is actually general enough to be able to integrate different tool chains.
Yeah. It's basically some tasks. You have create another task subclass task class and have some, we predefine some API and just go and implement them, and everything can hook into the system.
Another question is nobody asked. So I thought that you have a slide where you can say that you can actually hook up the you can get some, for example, register pressure information here, and you have a tool that can rewrite the code. I wonder if you have experimented with rewriting the assembly to get better register allocation, or that's not in the scope of this work.
You mean manually allocate registers? I'm not sure you can do this.
No, through the optimizer. Let's say you find a region, say, oh, okay, well, this value is actually in a loop and is loop invariant. I can move it, or I can any kind of you show that you're able to rewrite some of the kernels to get better overlapping. For example, you mentioned that to load asynchronously the B operand, you can issue that instruction earlier, and that's done automatically by your agent that does the rewrite on the kernel. I wonder if that agent also would work at the register level, at the assembly level, or that's like not in the scope.
I think the agent stuff, like I discussed this thing, it's basically a prototype to demonstrate. We want to see like how easy it is to build some agent based on MPP. It's not necessary that you can only work with. So we use TDGI because it's I think it's a sweet spot when complexity and performance optimization. But you can for sure you can have an agent rewrite the PTX and try to squeeze the performance. Surely you can do that, and the system would allow you to. You just need to construct your own workflow, your prompts, and stuff like that. Yeah.
I mean, and this agent require human intervention. You have to give it a prompt, or is the prompt generated by somebody else?
Yeah, we wrote the prompt. It's some like system prompt stuff like that. For user just say, okay, just go ahead and optimize this. That's it.
Okay, I see.
So we have any other questions, or other questions that people have? By the way, Kevin, this was a pretty nice presentation. Thanks very much for giving it.
Sure.
Okay, looking around. If not, I think Ofer, are you around?
Yeah, I'm here.
Oh, excellent. Okay. So if we don't have more questions for Kevin, we'll head over to Ofer. Ofer's going to give us a brief update on the Triton conference that's coming up really soon. I'll hand it over to Ofer.
Yeah, thanks. Let me quickly share my just my slides. Bill, can you see my slides?
Yep, looks good.
Okay, good. So yeah, just a really quick update about the conference. The third annual Triton Developers Conference. This is the main technical conference for our community. It takes place on October 21st. It'll be in the Microsoft campus in Mountain View, California. And it's a full day program. So, 9 a.m. is when the first talk will start. So, if you're attending the conference, please, show up before that, because 9 a.m. sharp, we start the whole thing. And then the program goes on until 4:30. I'll show you the program itself in the next slide. And then maybe the most important part of the meeting is 4:30 to 6 p.m. We have a happy hour, so just mingling and drinks and meet the community and meet in person. So for me, that's the breaks and the lunch and the happy hour at the end are the point of attending. So everyone is very, very strongly encouraged. If you feel that you're part of the Triton community or you contribute to something related to Triton, please strongly consider showing up and showing your face and meeting everyone in person. I think it's a really great opportunity. That said, all the talks will be live streamed and recorded. If for some reason you can't show up, then we're going to have that registration. If you are attending the conference, or if you also intend to view the live stream, you need to register either for in-person attendance, or if you want to, reminders about the live stream, or there's other things that happen when you register also for the online only version. But certainly if you want to show up in person at the venue, you absolutely have to register. So if you show up on the day of without having registered, they won't be able to let you in. This is the link. The conference is free, but we have a limited number of seats. We're limited to about 500 seats in the room. Right now, we're still pretty good. So we have over 200 people have registered, so there's lots of space left. If you register, I want to make just a comment here because this has been confusing to some people. When you register for the conference, your status appears as pending. And then it takes sometimes even as long as a week for that pending status to change to approved. And I want to explain that because I've been getting messages on, Slack and Discord about people saying, hey, help me get my registration from pending to approved. So Microsoft is being, this is on the Microsoft campus. This is an active campus, and Microsoft is being kind of extra careful about inviting outside people into the campus and so on. So when you register on this website, what happens is your name gets added to a list, and then it gets sent to the Microsoft security, and they, I don't know, do they look at the list, and so far everyone's been approved. So it's not like any kind of selection, but there is a little bit of a security thing, and it takes a little bit of time. My advice is please register with either an institution email or a company email or a university email or something that will give them a little bit of a hint about, or a confirmation about who you are and what you represent, where you come from, what your affiliation is. If you just register with your Gmail or some generic email, I don't know, I'm not sure what happens. If you already did, maybe it'll be approved. If not, reach out to me on again, Slack, Discord, or any other way, and I'll also try to help and vouch for you and get you in. But anyway, it takes a little bit of time. So go on there, register, use your company or university email, and then just wait a little bit patiently, and it'll turn to approved. At some point, we'll fill up the venue, and then it won't be approved. So when we have no more seats, there's fire code and stuff. They won't let you in. So that's that. The date, October 21st. Again, it's the day before the PyTorch conference, which is in San Francisco. So that's on October 22nd, 23rd. At the Moscone Center, and we have buses. So the idea is that people who are flying in for the PyTorch conference, if they come in a day early but want to still stay at their San Francisco hotel next to the PyTorch conference venue, we're going to be able to bus them back and forth to the Triton conference. So it's not, Mountain View and San Francisco are kind of close, but not exactly the same city. So that's the logistics, and let's quickly move to the program that I want to show you. So this is our program that we have right now. Again, 9 to 4:30 is the program. We'll start with a brief welcome. Someone from Microsoft will say, hey, welcome to our building, and we love Triton, and so on. And then we'll dive in to our first talk by Phil and Tomas about, it's called Triton Today and Beyond. This is kind of the state of the union of Triton. Actually, before I go and present these other talks, I want to say all the talks are full-length 30-minute talks. We didn't do any of these lightning talks or other kind of short things. They're all supposed to be deep, technical, get down to the nitty-gritty of it. And we really made sure to pick topics that were kind of mature for presentation and really, really state of the art and interesting. So I'm super excited. I'm looking forward to being an audience member in this presentation. It's going to be great. So anyway, we start with a full 45-minute keynote by Phil and Tomas about Triton, where it's going, where it's been, what's happening, and so on. Then we have our first break. The first session, the morning session, is kind of an ecosystem session, and we have 3 talks. Mark from GPU Mode will talk about the kind of aspects of building a social community around Triton and how GPU Mode has been involved with that. Jason will talk about Helion, which is a higher level DSL, and then Karen and Yuan Wei will talk about Proton, which is the topic that we just heard about right now. Again, deep technical, interesting talks in the morning about the kind of broader ecosystem. Then we break for lunch. After lunch, we have 2 sessions. The first session is the backends and low-level session. So we have talks from AMD and NVIDIA about all the work that went into building their Triton backends for their state-of-the-art GPU cards. And then we have Peter from OpenAI will talk about Gluon and present their low-level programming model. So that's kind of low-level after lunch. Again, we have a break, and then after the break, we have our final 3 talks, which is kind of a session around tools and libraries and extensions to Triton. We have Hong Tao will talk about TLX. Wen Lei from ByteDance will talk about Triton Distributed. And finally, Yanning from LinkedIn will talk about Liger kernel and how they've been thinking about their library of Triton kernels. And that's the end of our program. Again, I feel this is a really, really strong lineup of talks. So please, strongly consider tuning in or coming in person. And then, of course, the happy hour. So, maybe the most important part of the day is hanging out with some beers and stuff, and just getting to know each other a little bit better. So that's our program. Again, please register. By the way, especially if you're coming from outside the US and you need a letter for your visa, I think you should get going and register quickly, and then we can help you with that. We can send a letter for the embassy or whatever to get you into the country. But just in general, secure your seat. Go to the registration website. Again, use your corporate email or university email or some kind of professional email would be advisable or preferable, although not mandatory. If you have lingering problems, like if you register and a week passes, you're still pending, shoot me a little message and I'll help you out. And that's it. Please register. Please attend. Thank you.
All right, Ofer. Thank you very much. I really appreciate the fact that Microsoft's throwing this and you're sponsoring it, and I think it's going to be a really great meetup. Do folks have any questions that Ofer hasn't answered? I think some of the big ones you did answer were the ones about making sure that people got the feedback. Like, yeah, if I registered, when I'm getting feedback about accepting accepted. I think that was a big one that came up a couple times in our Discord chat. So glad you answered that. Any other questions folks have? If not, thanks again, Ofer, and I will pass it off to questions. So some questions we got some questions that, if you have questions, please add them to either the Slack or to Discord, and we'll answer them. First question that came up was to members of the community who are here, who's using Triton Bench? This is something that we were kind of interested in, and I think some other folks are interested in the environment. How are you using it? And the other one is asking OpenAI in particular, are you using Triton Bench too, and how are you using it? So just kind of looking around the room, maybe some folks could actually tell us what they're doing. I don't know, Simon, if you want to go first, because I know you're using Triton Bench.
Yeah, actually, Brian has some update on that.
Brian there? Yep, there he is, Brian. Kernelize AI. Okay. Whoops. If you're talking, Brian, you're muted.
How is that? Is that better?
There you go. We can hear you now.
All right, it's much better. We're working on Triton related to the LLM, and we wanted a consistent way to test things. So we started just testing Triton Bench nightly as a way to figure out how to do these tests. We built the visualization I can show you some pictures of the visualization if you're interested, and have run some tests from Triton 3.3 and 3.4 and found some specific things on H100 and B200 that, they're not validated yet. So I don't know that it's worth going deep on them, but it does look like there might have been some regressions on lighter kernel and then maybe something around BF16 on those two devices. So we're using it to support the community to start with, but really our goal is to deploy Triton Bench on testing some things around VLLM, kernels for VLLM.
Okay. Other folks are using it? Otherwise, I'm going to ask the folks over at OpenAI if anybody could give us a rundown of how you're using Triton Bench. Either Thomas or Phil. Phil's around. Thomas?
We're not using it.
Okay. All right. Hong Kong? Did you want to say something? Or Xu?
Could I ask an add-on question? What are you all using? How do you test this stuff?
Good question. This is to OpenAI, right?
Yeah, to OpenAI. Sorry. Yes.
Okay. No worries.
Wait, sorry, the question was to me?
Yes. Basically, if you're not using Triton Bench, what are you using internally?
Oh, I guess we have our internal benchmark system.
Okay. Is there a reason, or I was just kind of curious, would you be willing to open source any of that, your internal benchmarking system, or at least some of the tests that are in the internal benchmarking systems? Or are you noticing there's things you would like to see in Triton Bench that we currently don't have that would be useful to have?
I mean, it's fairly low-tech stuff, to be honest. I mean, most of it is just our kernels that we cannot open source. I mean, we open source some of them that are in Triton repo, but we cannot open source all of them. And it's really a simple benchmarking environment on top of that. There's really not much to open source.
Okay.
Thomas, it looks like y'all haven't uploaded any new kernels in a long time. Is there any plans to make any more of those open?
I mean, it's work in progress where we are continuously working on those kernels. There were talks about like potentially upstreaming more, like mostly like attentions and stuff like that, but it's not clear to me when and whether it would happen or not. But I mean, the MOE stuff, we keep them up to date, and we're going to continuously like develop them upstream.
Great.
Okay. Any other comments from folks?
Is it? I mean,
Right.
Is there anyone else interested in this? Like I said, there was a question on this. We've built a UI on top of Triton Bench to help with analysis. We can run on B200s every day if you need to. But I mean, it would be very interesting to me to maybe not here, but just to hear from the community. Like, what do you want to see tested? Because definitely it looks like there are things that have regressed, maybe that got missed. It would be nice to know what's comprehensive testing and what devices do you want to test it on?
I think one talking about regression, this end-to-end tests, they take time. I would like to see better coverage with lit test in the OpenAI repository. If there are regression, that I would think that there is an opportunity to cover this at the lit test level, which does not require you to have a GPU or to run on, it doesn't require any of the driver, any of that. And it's easy, fast to run. As opposed to, test the operator end to end.
All right. Other folks, any other companies would like to chime in, or any other installations of Triton like to chime in? If not, I will head over to our second question, which I think is also a testing question too. The Triton testing strategy. So, Ettore, I think you kind of like led into this one, which is given the current state of Triton testing and how it's been set up, what do folks think about where it's currently at right now, and what are we missing? And I'm glad you brought up those lit tests, so that's great. And
not to say that there are I don't want to say, I have to clarify a little bit. I am not saying that the 20,000 plus unit tests that we that we run are actually in OpenAI are not good and don't provide sufficient coverage. But it occurs to me that if you want to spend some effort in improving regression testing, then one way to do it is to beef up the lit test, which because they're much faster to run and they're not so dependent on a GPU or another, right? Like, I mean, there are part of it that will be they check the code gen for that particular GPU, and those they belong in a third-party testing section for a particular GPU. But anything else that is common in the Triton GPU dialect, Triton IR dialect, and stuff like that, perhaps there is, if you find a problem, then essentially just add a lit test to those regression testing suite.
Okay. Sounds good. So are there any, looking around the room for other folks who are online, are there other types of testing that we should be doing, or we should be thinking, that the community should be thinking about implementing that we currently don't have? And just wondering, other than like the ones that run quickly, are there other types of tests that we currently don't have right now that you think would be useful, that maybe if we had more people, or if we had people who were interested, they could actually implement those kinds of tests? Nobody likes to write. I'm sorry. No, but people like writing tests. Not saying that nobody wants to write tests, but it's one of those ones that comes up as like I think if, like, as Brian was noticing, there might have been some regressions that were pushed out between like 3.3 and 3.4. If there are other types of testing that we should be doing that currently we aren't doing, I think it would be kind of a good one to bring up. I think some other ones that came up were numerical stability. Those certain types of tests which are kind of difficult to write, and depending upon like what type of algorithms you're using, but some are actually. Let Alex, I'll let you talk.
Yeah, I'll bite it. Tests that I'd like to see, which I think I brought up here before. But anyway, I mean, I think for the important set of kernels, whatever those are,
Mhm.
the IR diffing is something that's kind of interesting, right? Because it's much cheaper to run per PR run or whatever, than to reserve a whole B200 machine, and it'll tell you if the IR doesn't change, then you really should not have a regression.
Mhm.
Now, the IR changes all the time, so it's hard to get signal out of that. But if anybody's interested in working on that, message me on Slack. It's not clear that I have any time to work on a framework to actually compute the diff, right? I mean, you can use tooling and LLVM to eliminate white space changes and blah blah blah. But I think that would be a kind of interesting way to avoid, or to really, it's a way to identify the regression sooner, because we can't realistically run hours and hours of benchmarks on every BR. So if you have important kernels and you extract the IR and you have a way to do a comparison and identify whether that whether the results of that diff indicate a change, or just noise, white space noise or whatever, then I think that could be a useful signal. And if you want to work on that, please ping me on Slack or something. I'd be happy to try. And I think I need a partner in crime though, because I'm not sure I'm going to have time to get it going myself. But if anybody's interested, please let me know.
Excellent. That sounds great. So, folks are interested, ping Alex online, and hopefully we might be able to get something going there. All right. And I know I said that we have room for more questions, free mic for other questions that people have. But I want to ask one real quick, because this one's near and dear to my heart, because I work right next to the Python team who are doing things with free-threaded Python. And one thing they recommended, or they asked me to do, is like, well, when will Triton be amenable to free threading? And even if it's not amenable, I think they were thinking about, like, if we could just add some annotations to Triton so that if a person wanted to use free threading, at least we know that the whole Triton section was unsafe. Or kind of curious about like what people think about that, or if there's anybody who's actually working on enabling free threading for Triton. And I was going to pass that open to OpenAI. If anybody at OpenAI has any interest in actually answering that question. Hey, Thomas.
I can take this, yes.
Okay.
It is not something we've looked in detail at. I mean, we've been doing like a lot more multi-threading recently. We've not looked at free threading. Yeah, I'm guessing there's a bunch of stuff to fix in the front end for sure. The back end itself should be fairly thread safe. But yeah, I would imagine there's some work in the front end and probably some re-architecturing. It's not clear when we would want to transition to that though.
Okay. Not high on the list. The other one too is if anybody wanted to actually start to work with some of the annotations, I think at least we could like put some initial annotations that the most of the code is not free thread safe. So at least when they're doing the analysis, it knows to, hey, by the way, this whole chunk of section which calls Triton should actually be considered to be one thread and shouldn't actually, you shouldn't start free threading inside of it. But then as people go through it and you've actually done more analysis to figure out like which parts are free thread safe, we can like start decreasing the range that exclusion block covers. So maybe I might give that a try, or I might be able to find somebody who might be able to try that. Okay, so we got about 2 minutes left. I'm gonna open up the floor. Do people have other questions that you'd like to ask or that you're interested in? Either Kevin, who spoke earlier on MPP, any of the work from Ofer, when he was talking about like the work at the Triton Developers Conference, or like anything else that folks have to talk about.
I do have one.
Go ahead, Whitney.
Yeah, so when we have introduced the tensor descriptor, I know it was originally for TMA. And so there's a lot of leftover naming convention that have the TMA there, like no matter in Triton internally or in PyTorch, let's say flex attention, it's have keyword like that to say use TMA. But actually tensor descriptor now can be used even if you don't have a TMA. Is there plan to rename all these variables?
In what code are you, like what code are you referencing?
So one particular I'm mostly interested is in flex attention in PyTorch. It have different implementation. One say use TMA, then it will use tensor descriptor, or else it would just use like regular pointer. And I think like these kind of variable will be confusing on some platform doesn't have TMA, but want to use tensor descriptor. So if we can name it, for example, use tensor descriptor, or even just whenever the pointers is considered contiguous, that can be used at tensor descriptor, then just use it by default, because I think there's like fallback path to regular pointer even if there's no TMA support anyways.
This came up very recently because there is some changes in PyTorch a week ago or so, where they know that the block pointers are deprecated. So a person, I forgot, they basically say, okay, well, I'm going to remove the block pointers, and they didn't replace it with tensor descriptors, but the tensor descriptor path is protected by a macro called useTMA. And what that really protects in that particular piece of code is the use of tensor descriptor. So we are thinking, speculating that there is a misunderstanding how tensor descriptor work. Tensor descriptor, they don't need the underlying hour to have TMA support. So it's not for in the Triton code base, it's in the PyTorch code base. So the AR should be within PyTorch to do a cleanup and use a variable that is more, I don't know, that either use TMA where TMA is really needed, or don't use it at all, or change the name. And maybe Bill, you already know.
I'll take that. I'll take that because I know the person who actually wrote that code, and I will escalate that to him. So thank you very much for waiting. So I'll hopefully get that taken.
And Cicie, another comment here, like the flex attention implementation has a forward and a backward pass. Currently, the forward pass you can use tensor descriptors, but in the backward pass, unless it's changed recently, even if you use tensor descriptor for the forward pass, the backward pass will use tensor of pointers, which seems an inconsistency. If you are using tensor descriptor on the forward pass, I guess you would be more consistent to also use them in the backward pass. And if that change can be done, that would be great.
Okay, excellent. I think that's another thing that they're still working on right now. They're still working on actually rolling that out. So it might be the fact they're like in the middle.
There was an initial confusion that tensor descriptor are only for TMA support, but they're not.
And to make this question more general though, so the one that really triggers our question is the flex attention, but even in Triton, there's like function called support TMA. And then if it's support, then it will use the tensor descriptor. So this is throughout many places, not just flex attention. Yeah.
Okay. All right. So it sounds like we have some cleanup work. There's some like tech debt that has to be cleaned up. Excellent.
Yeah. Thanks.
Okay, thanks. So I want to say thank you very much. We ran over by about 2 minutes, and I will be posting all this online so you can actually review them later. And thank you all for joining, and thanks once again for bearing with us while we got the meeting IDs straightened up in the very beginning. All right,
Thanks, Bill,
talk to y'all
for
later.
organizing. Bye-bye.
Thank you. Bye bye.
Thanks.